So we looked at horizontal shifts and vertical shifts of the graph. Now we're going to look at reflections of the graph. So this is where we kind of take the graph and we reflect it to a different part of the graph. In other words, we make a mirror image of it. So I want to look at the graph f of x equals the square root of x this time. The reason I don't want to look at x squared this time is because x squared is actually symmetric around the y-axis, so we wouldn't be able to see the reflection. So the square root of x graph, first of all, we can't take the square root of a negative number, so we're only putting in positive x values, right? It's better to use perfect squares here, but you can put any positive number in here, okay? So we use these set of points to keep track of it. So we have 0, 0, 1, 1, 2, 4, 2, not 2, 4. Okay, and then we would have a point out at 9, 3 as well. And it's only going in this one direction. It's kind of cut off at 0, 0 because there are no negative inputs and there are no negative outputs in this base graph. So if we were to then instead look at the graph of, let's say, g of x equals the negative square root of x. So now we're taking the square root of x and then we're negating all of the values. So this is kind of like the vertical shift in that we're just doing the function and then we're doing something to the outputs afterwards. So we're just going to end up negating the outputs. So 0 is not going to change, right? Negative 0 is just 0. There's no such thing as negative 0. 1 becomes negative 1. 2 becomes negative 2. 3 becomes negative 3. Okay. So we're going to have a point at 0, 0. I didn't label any of the y-axis values because I didn't need them. But now we'll go ahead and put those in here, right? 1, negative 1. 4, negative 2. So it's going to look something like this. So it's going to be a mirror image over the x-axis, okay? So because the outputs are along the vertical axis and we're negating the outputs, we're flipping them over the x-axis. So we say that negative f of x is a reflection of f over the x-axis. Okay. And if we're thinking about the order here, we had horizontal shifts as 1, and I said vertical shifts will always be at the end. So here we're just multiplying the outputs by negative 1. We're multiplying. So that's going to fall in between here, right? So we're going to have reflections. Okay. Now, of course, if we have a reflection over the x-axis, naturally we're going to have reflections over the y-axis. So why don't we just stay on this graph and we can look at what that looks like. I'm just gonna, okay, I wrote a new set of points up here at the top. So we'll do this one in green, I suppose. So let's look at this new function h of x equals the square root of negative x. Okay, so this is a little bit strange because, we can't take the square root of a negative number, but that doesn't mean we can't have the square root of negative x. This just means that our x values now have to be negative because if you put negative 2 in for this, you'd have negative 2, which is positive 2, and you could take the square root of that. So this is still a valid function, even though we can't take the square root of negative numbers. So naturally, this is just going to negate the inputs, right? We're going to do the negative of the inputs, and then we're going to take the square root of them. So again, 0 doesn't matter here, but this 1 is going to become negative 1, right? If we put negative 1 into this function, we'll have negative negative 1, which is 1, and then we'll take the square root, which is positive 1. And then same thing with 4, this will be negative 4. So if we do negative negative 4, that's positive 4. So we get the square root of 4, which is 2. Okay. So we have, then we're going to have points on this side of the graph. So we have a point at 0, 0 still. We have negative 1, 1. And we have negative 4, 2. So it's going to look like this. So our outputs are still positive, but now our inputs are negative because they need to be in order to cancel out that negative on the inside. But ultimately, we see that this is a reflection of f over the y-axis then. Because we're negating the x values, we're sending them to the other side of the y-axis. Okay, so we'll write that down here. F of negative x then is a reflection over the y-axis. Now, if we're thinking about the order with the reflections here, the order of the reflections themselves actually don't matter. We can do the reflections in either order, but they do need to fall between the horizontal and the vertical shifts. And you might have been thinking in the last video, why does the order of the horizontal and vertical shifts really matter? Because if you tried it out with just the horizontal and the vertical shifts, like if you shifted vertically first and then horizontal, you would have seen that they were the same thing. But in this case, when we're adding in reflections and later when we're adding in stretching and compressing the graphs, the ultimate overall order will matter. We will need to do the horizontal shifts first, then the reflections, then the vertical shifts. Okay, so independently, when you just have horizontal and vertical shifts, there's no need to pay attention to the order. But when you start adding reflections in, then you do have to pay attention to the order, because otherwise you're going to end up with different answers. So let's do one example with everything we've seen so far. Okay, let's do f of x equals the negative square root of negative x minus 3 plus 2. Okay, so we have a reflection of each type, a horizontal shift and a vertical shift. So again, we can do all of these transformations step by step, or we could just look at the points of where they're supposed to end up. We can just do both, so we can see what both of those looks like. Okay, we'll just keep track of these 3 points to keep it simple. Okay, so first we want to apply the horizontal shift, so we want to add 3 to these points. Okay, so we have 3, 0, 4, 1, 7, 2. Now we want to reflect on both of them. So you can see now that the order would matter. If we negated the x values first and then added 3, these would be different, right? So we have negative, negative, negative for the x values, and we can do the same for the y values, right? We could just say that's 0, don't have to cross it out. So 0, negative 1, negative 2. And again, the order of those reflections don't matter. We can negate the x values first and the y values. It doesn't matter. We're ultimately going to end up at the same thing. And then finally, we're going to add 2 to the y values. So we have a point at negative 3, 2, negative 4, 1, negative 7, 0. Okay. So now let's do a series of graphs and see where we end up with. So we're going to need ultimately 5 graphs for this, right? We're going to need one for the parent graph and then one for each transformation, of which there are 4. So that's why we just do them quickly, because otherwise they could take quite a long time. So we have this for the parent graph. Okay. And then we do the horizontal transformation by 3. So we have a horizontal shift 3 to the right. So that point at 0, 0 is now at 3, 0. That point at 1, 1 is now at 4, 1. And then the point at 4, 2 is now at 7, 2. Okay. Now we're going to do a reflection. It doesn't actually matter which one we do first. Let's just do the horizontal one. Oops. Or rather the input ones, which will be the vertical one. Or sorry, yeah, it is the horizontal one over the y-axis is what I mean. So the point that's at 3, 0 will be at negative 3, 0. The point that is at 4, 1 will be at negative 4, 1. And then the point that is at 7, 2 will be at negative 7, negative 2. Okay, so we're going to look like this. Now we do the other reflection. So we're going to reflect about the x-axis. Okay, so all of those points are going to be negated, all the outputs. It's 1, 2, 3, 4, 5, 6, 7. So the point that's on the x-axis, of course, doesn't move. The point that's at negative 4, 1 becomes at negative 4, negative 1. And negative 7, 2 becomes negative 7, negative 2. Okay, so it looks like this. Finally, last but not least, we have the vertical shift. I'm forgetting how much it even was at this point, because we've done so many steps, plus 2. Okay, so our final graph, 3, 4, 5, 6, 7. So we have negative 3 zeros going to negative 3, 2. And then we have negative 4, 1. And negative 7, 0. Okay, so it'll look something like that. Kind of slanted the x-axis there, but it'll look like that. Okay. And we can check with our points here. Right, we did have negative 7, 0. We did have negative 3, 2. We did have negative 4, 1. So this method up here, like just working with the points, obviously much quicker. Here you kind of get a better understanding of what's going on with the graph, like what every individual thing is doing, but obviously way more time consuming. I would probably recommend getting comfortable working with the points. And then maybe you can verify your answers with a graphing calculator as well. I'm going to switch over to that window so we can look at that. So this is the graphing calculator website I was talking about, Desmos. If you just have a graphing calculator, of course, you can use that as well to check any of your answers. But this is a nice handy tool when we're looking at the more complicated graphs. We're often going to want to have a visual picture of the graphs. So, ideally you can come up with a quick sketch of them by hand rather quickly after enough practice. But this is another website to look at just for when you're practicing to verify your answers. So we can kind of see just, you can also kind of play around with it just to see how different things affect the graph, right? Like if we don't add 2 here, if we take out maybe a horizontal shift, we see it goes all the way back. Take out the vertical shift, take out the, well, that's actually multiplying by 3. So here you can actually see what happens when we're going to start multiplying by numbers, right? So you can see this looks pretty different, and then you can compare it to graphs too. So if we want to compare it to the square root of x graph, we can see that this is what changes with the square root of 3x. Maybe we want to see what happens with 3 times the square root of x. How does that change, right? So we can see all the different things. This is a nice, useful tool for comparing different graphs and seeing exactly how these transformations affect things.